Hello my dear students, welcome back for the next lecture. Today's topic is capacitance of a parallel plate capacitor. In the previous lecture we have done capacitance of a spherical conductor which is isolated. But today we will do capacitance of a parallel plate capacitor. Now what is a parallel plate capacitor? What is a parallel plate capacitor? As the name indicates, parallel plate capacitor is made up of two parallel plates. जैसे for example this is one parallel plate. मैं थोड़ा 3D बनाने की कोशिश करता हूँ. This is a one plate and other plate is kept at some distance apart and it is kept parallel to itself, parallel to the first plate. ये एक प्लेट है, ये दूसरी प्लेट है, दोनों आपस में एक दूसरे के पैरेलल हैं and they are separated by some distance. मान लेते हैं इसका सेंटर टू सेंटर ले रही है डिस्टेंस. This distance is say d. और इनका एरिया कितना है? दोनों का एरिया सेम है, सेम एरिया, exactly same, and they are kept parallel to each other. And these are rectangular plates. These are rectangular plates. इसका एरिया कितना है? Its area is a. इसका एरिया भी a है. तो parallel plate capacitor consists of two conducting plates parallel to each other and separated by a distance which is small as compared with the linear dimensions of the plates. ये जो distance है, ये distance इसकी linear dimension से कम होना चाहिए. तो यहाँ मैंने थोड़ा ज़्यादा शो किया, but it is very very small distance. And the parallel capacitor consists of two conducting plates of equal area. Kept parallel to each other and separated by distance which is small as compared with the linear dimensions of the plates. So this is a parallel plate capacitor. और इसमें हम क्या करते हैं? इस प्लेट को say for example प्लस सिग्मा चार्ज डेंसिटी की और इसकी माइनस सिग्मा कूलम पर मीटर स्क्वायर इसकी चार्ज डेंसिटी. both are equally and oppositely charged. तो इसके अगर चार्ज डेंसिटी पॉजिटिव है तो it is say positive in nature and these plates are very thin. These are thin plates. And अगर ये पॉजिटिव है तो इस साइड क्या होगा? इस साइड क्या इंड्यूस होगा? ये इस साइड से देख रहे हैं तो इस साइड नेगेटिव इंड्यूस होगा और यू कैन सी वी आर गिविंग अ नेगेटिव चार्ज टू इट. अगर ये पॉजिटिव प्लेट, इसको हमने पॉजिटिव चार्ज दिया, उसको हमने क्या दिया? नेगेटिव चार्ज दिया. इस साइड से अर्थ कर सकते हैं, अगर नहीं भी किया नो प्रॉब्लम. What is the charge this side? It is plus q. What is charge this side? Is very thin. Same charge. This is minus q. So what is the charge? It's a very thin sheet. Plus q charge is here. Minus q charge is here. अब बाहर से अर्थ कर सकते हैं. But at present, these are two plates which are kept parallel to each other. One is positively charged, other is equally negatively charged. And what is the area of the plates? It's a. And what is the distance of separation? It is d. And what is sigma? Is surface charge density. Now you know, अगर कोई point यहाँ पे हो, यहाँ पे, तो ये we have done this in the application of Gauss's theorem. So what is the electric field here? तो see here, इसकी electric field यहाँ से इधर जाएगी. ये negative है, negative की electric field भी इधर ही जाएगी. तो इस point पे if you take a Gaussian surface, तो what you will find? इसकी इलेक्ट्रिक फील्ड कितनी होती है? इस थिन प्लेट की E equals to sigma by 2 epsilon naught. और इसकी भी कितनी होती है? E equals to sigma by 2 epsilon naught. तो अगर हम दोनों को नेट करेंगे, नेट इलेक्ट्रिक फील्ड क्योंकि सेम डायरेक्शन में है. दिस इज पॉजिटिव, पॉजिटिव से बाहर निकलती है और नेगेटिव से एंटर करती है. दिस इज द इलेक्ट्रिक फील्ड बिटवीन द टू प्लेट्स एंड इट इज यूनिफॉर्म, इक्वली स्पेस बराबर. And what is the magnitude of electric field? It is sigma by 2 epsilon naught plus sigma by 2 epsilon naught. This comes to be sigma by epsilon naught. तो जिन बच्चों को समझ में नहीं आएगी E equals sigma by epsilon naught कैसे है? It is by applying Gauss's theorem और ये मैंने separately करवाया हुआ है पिछले लेक्चर में. By applying Gauss's theorem, we can find the electric field inside the two parallel plates which are equally and oppositely charged, and it is equals to sigma by epsilon naught. So what is electric field inside the plates? It is sigma by epsilon naught. So before I rub it, let's see what we have taken here. We have taken a parallel plate capacitor having a separation distance d with charge density plus minus sigma and with area A, and the electric field in between the two plates is sigma by epsilon naught, and it is uniform. What is the electric field outside the plates? It is, ये भी मैंने पहले बताया, it is zero. It is zero. हाँ, यहाँ से प्लेट से यहाँ ऐसे इलेक्ट्रिक फील्ड आ सकती है, ऐसे एजिस से, ऐसे नीचे से भी आ सकती है, एजिस से, उस साइड से भी आ सकती है. तो इग्नोरिंग द एज इफेक्ट्स, इग्नोरिंग द एज इफेक्ट्स, अगर हम एज इफेक्ट्स को इग्नोर कर दें तो हमें क्या मिलेगा? इलेक्ट्रिक फील्ड बिटवीन द प्लेट्स, बिटवीन द प्लेट्स कितनी? E equals to sigma by epsilon naught, ये बीच में. And electric field outside the plate, outside the plate कितनी electric field है? It is zero. So see, this is equation number 1. So electric field outside the plates is zero, and between the plates is sigma by epsilon naught. And this derivation is explained by me in my previous lectures, applications of Gauss's theorem. Now, what we have to find? We have to find the capacitance. For capacitance के लिए what is the formula? C equals to Q by V. V is the potential. So let's find the potential between the two plates. The potential, you can say the potential difference between the two parallel plates. So what is the potential? Formula of potential difference? V. V equals to ED. Now again, from where it comes? मैंने पीछे डेरिवेशन से बताया E equals to minus dV by dr. तो आप यूज कर सकते हैं E equals to, remove the sign E minus, so we can use E equals to V upon R, so V equals to ER, or you can say V equals to EL भी use कर सकते हैं, or V equals to ED भी use कर सकते हैं. So this is a formula used, equation number 2. V equals to E into D. What is E? E is the electric field and D is the separation distance. So what is the electric field inside the plate? It is sigma by epsilon naught into D. And what is the formula of sigma? Sigma is surface charge density. It's Q upon A. So this is equation number 3. V equals to ED. Put the value of E. What is sigma? Sigma is Q upon A. So Q epsilon naught A by A into D. This is the potential difference between the two plates. And this electric field is in between the two plates. Outside the plates it is 0. तो हमें outside तो निकालना ही नहीं है. So what is the capacitance now? Now we know that capacitance. We know that capacitance is given by C equals to Q upon V. So put this value of V here. So C equals to Q. What is the value of V? QD. QD denominator में आ जाएगा और इसको करेंगे तो QD epsilon naught A. This comes to be C. What is C equals to? Epsilon naught A by D. This is the required formula. So what is the capacitance of the parallel plate capacitor? It is C, which is equals to epsilon naught A by D. Please learn this formula and it should be on your tips. What is the capacitance of a parallel plate capacitor? It's epsilon naught A by D. What is epsilon naught? Absolute electrical permittivity of the free vacuum. Here it is vacuum. And what is A? A is the area of the plate. So what is D? D is the separation distance. Now, how? तो इससे आप अगर हम इसको replace कर दें, if the space is replaced by some medium, अगर हम इसको medium डाल दें कुछ, तो what is the capacitance in the medium? It is epsilon naught A by D. This is capacitance of the parallel plate capacitor, parallel plate capacitor with a medium of dielectric constant epsilon naught. तो अगर हम इसको फिल कर दें, इसके अंदर हम एप्सिलॉन नॉट डाल दें, वैक्यूम को रिप्लेस करके किसी वैक्स डाल दें, ऑयल डाल दें, वाटर डाल दें, कुछ भी डाल दें, कुछ भी डाइलेक्ट्रिक मीडियम डाल दें, तो व्हाट इज द कैपेसिटेंस? कैपेसिटेंस विल बी एप्सिलॉन नॉट एप्सिलॉन आर A into D. The capacitance will increase epsilon r times. It will increase. You will find here C dash is epsilon r times C. What is C? C is the capacitance in vacuum and C dash is the capacitance in the medium. So C dash increases. Now there are different ways to increase the capacitance. How the capacitance can be increased? Capacitance can be increased here from this formula. What is the capacitance? This capacitance is directly proportional to area and inversely to distance. तो हम कैपेसिटेंस बढ़ा सकते हैं, पैरेलल प्लेट कैपेसिटर के कैपेसिटेंस बढ़ा सकते हैं अगर हम एरिया ऑफ द प्लेट्स बढ़ा दें, बड़ी बड़ी प्लेट्स ले लें और साथ में सेपरेशन डिस्टेंस कम कर दें. टू पॉइंट्स. एंड थर्ड पॉइंट, अगर हम जो मीडियम है प्लेट्स के बीच का जो मीडियम है उसको हम रिप्लेस कर दें किसी डाइलेक्ट्रिक मीडियम में. And every dielectric medium has a dielectric constant which is greater than 1. वैक्यूम का 1 होता है, बाकी सबका 1 से ज्यादा है, तो उससे हम कैपेसिटेंस बढ़ा सकते हैं. तो how to increase the capacitance of a parallel plate capacitor? By increasing the area of the plates, by decreasing the separation distance, and by inserting some dielectric medium. To see here once again, what is the potential formula? V equals to ED. E का formula हमने derive किया, E equals sigma by epsilon naught. It is between the plates. D is the separation distance. Sigma is Q upon A. This is the potential between the two plates. We know that capacitance is C equals to Q upon V. Put the value of V from this equation here and solve it. This is the capacitance of a parallel plate capacitor with a vacuum. This is the capacitance of a parallel plate capacitor. अगर medium डालते हैं तो उसका ये formula बन जाता है. Capacitance को increase कर सकते हैं, area को बढ़ा के, distance को कम करके और बीच में dielectric medium insert करके. That's all for today. Thank you very much.